And I want to open code blocks, and I'll share my screen for code blocks. Okay. So I'm going to share screen. So we want to create, what do we want to do? Let me just save it so that we'll have a C formatted document. And what we want to do is the 6 nodes, right? So stacks and queues. So stack queue dot C. All right, so we're going to do it in the same. File. Let's just specify what we want to do. We want to write a C program that allows a user to enter numbers into both stacks and queues. The program should print a menu to the user, and when a number is entered, it is stored in both the stack and the queue. Whenever a value needs to be taken out of the various structures, we will pop a value. We will pop a value from the stack and dequeue a value from the queue. We also wish to have a function that displays of both the stack and the queue. Okay, and again, we are just we are approaching the stacks and the queues.
So
Yeah.
I think after you put both the TSC queue.
Oh, stack, yeah. So right. Yeah. So I also think that, Jaden, I like that idea that you posted in the chat. It's off that great start with me not knowing, even though I know now that that's probably going to happen. Right? Just vary the homework accordingly, and you all should be good. All right. So we want to start the program. Everybody understand what the program involves? Should I? It's just simply we enter in values, we take in one value, we enter it into a stack and the queue same time. We removing a value, we removing it from both the stack and the queue same time. The program is going to print or visualize the contents of the stack and the queue. There's no greater purpose to this program than simply us being able to explore the functions associated with stacks and queues. Any questions about this so far? All right, we're going to be using arrays to store the stack and queues. So we want to have include stdio.h, include stdlib.h, right? Define max, or let me say size as 25, right? So this is the size, the maximum size of the array used to store the stack and the queue. Okay. Int mean, we have mean as well. And what do we want to do from here? What do we want to do from here?
So you want to create the stack?
Right. Well, we want to create the stack and the queue. Right. Against better programming standards, let's use them as globals, right? Because we'll be breaking things up into functions, and we know that we have functions associated with stacks and queues. Okay, so we'll have the int arrays int stack, which will be of size max, queue, which will also be of size max. Okay, so this max here, let me see something. Okay, I'll fix that in a second. All right, I'm gonna go 25 there, and 25 there. Maybe my formatting for this is off. Let me just check if I'm. No, it's not. But image 10. Okay. All right. Well, for now it's 25. I should be able. This is correct as far as I've written it, but for some reason it's not taking it when I. Oh, I put size, not max. So nobody could have told me that I changed it from max to size.
So I was going to tell you, so I swear I was.
Yeah, but then you prefer to see me suffer on video, right?
Yeah,
I swear somewhere you all probably just be like chuckling to yourself, like, ha ha ha, how could he make that error when you watch over the video? This is assuming that people watch over the videos, right? You all do watch over the video, right? Don't all answer now, just okay. All right. Thank you, that one student who, probably just said it to make me feel better. All right. Yeah, all right, good. So we have size, sorry. I tell you this afternoon class thing, the afternoon class thing, let's just have to be head in a different zone, right? Okay, so we have the stack, we have the queue. We know that we have some what you call it? Some functions associated with stacks and queues. Could we name the functions associated with stacks again? From last class that I went through, the functions that stacks use to be able to define their behaviors and operations. But that's the one for Q, Joshua.
Oh, and just push and pop.
Right. So we have push and pop. So we have two functions, push and pop. So we want to declare these functions. Okay. So this is the arrays that we will use to store the stack information. And also we want to have push and pop. So we have void push because push, right, doesn't return any values, but push will take in an integer value. Okay, so the stack function to add a value to the stack, and we will have to define all of these functions. There's a lot of there's a lot of stuff that we're trying to get all in one class today, but we'll get it. I think within an hour we should be finished. Okay. And then we have int pop. And this is the stack function that allows us to remove a value from the stack array. For the queue function, for the queue behaviors, what are the functions that we have? We have void enqueue, right? This is the one that has a shared in the chat, and it'll take an integer in. And this is the queue function that allows for a value to be added to the queue. And we have int dequeue dequeue, right? I mean, and the crazy thing about dequeue is that you could probably just spell it like that, dequeue. And I mean, it'll be the same thing. We have about 5 extra letters that we don't need inside of this function. The queue function, so this is the queue function that allows for a value to be removed from the queue. We also have, and I'm going to put a space between these. We also have another set of variables that we can use that are associated with stacks and queues. A stack needs to have what variable associated with it. Okay, Jaden, those that you asking me, they're coming along as well. So you actually gave a perfect answer here, but for a question that I haven't asked yet. So, but what variable is associated with stack and what variable is associated with queues? What variables are associated with queues? Come on, folks. Answer up. We spoke about them last class.
He was asking a question.
What? Yes. Again, the inflection at the end of the statement indicated, inquisition. What variables are associated with both stacks and queues? It started with the word what? It's a question. Hey, it's really the end of the terminal.
Int? I'm not sure.
Not an int, the name of the variable. We know that a stack has a what? Where do we take values from in a stack? We take values, we have int top. So the top of a stack starts off at -1, right? And where do we take variables from in a queue? I mean, given the value, given the value inside of the stack that we use. Come on, what is the variable that indicates where we should not take values from in a queue, where we should add values to in a queue? That would be what? That would be the end of a queue, right? So the end of a queue is -1, and we start. So top is the marker for where values are added / removed from a stack, and end is the marker for where values are added to any queue, right? And of course, we could always define the start of a queue as position 0. So the start of a queue will always be position 0. So this is where, this is the position where we take values from the queue. Okay? Everybody with me so far? Or do I have to break out the whiteboard? I'm asking a question.
Not with you.
You're not with me. You can't remember what we're doing in terms of stacks and queues. So we go into the whiteboard. All right? We are going to the whiteboard. And I blame myself a little bit because I don't think that I uploaded the last class that we did as yet. So I don't think that you all got a chance to review what we did. So for our stack, we had this structure here. And if the stack is empty, then the value in terms of top would be at the index position -1. You all remember this? And for queues, our queue looks like a normal array in terms of being lined down on its side. And the end of the queue could be at position -1. And the start value for our queue kind of stays at 0 because we're dealing with the most basic of queues at this point. Is this jogging your memory?
Yes, sir.
Right? So now you have context in terms of the purpose of top and the purpose of start and end. Yes? I need communication, people.
Yes, sir.
Yeah? All right. So if it is that I want to add a value to a stack, I would push a value onto my stack. And if I push 20, what would happen is that 20 will go in the first available position or the next available position, coming to the top of my stack. So if I say 20 here, what happens is that the top of my stack moves to position 0. If I push another value from onto my stack, push 15, then the top of my stack will become this, and 15 will be stored in the top value. If I pop a value from my stack, it means that the value of 15 is going to be taken from my stack. Yeah? The value of 15 will be taken from my stack and the value in top will go down. Same thing with the queue. This is quick recap, because we do have the full explanation from last class, and I will, after this, I will go and I'll see if I can upload last class so that you guys could get a chance to recap it and go over it. Okay? The same thing with end. And if we enqueue a value, right, 20, then 20 goes here. If it is that we enqueue 15, 15 goes here. And what would have happened is the value for end, the value for end would have moved to where 15 is. If we dequeue the value 15, right? If we dequeue, sorry, the value, not 15. If we dequeue an operation on the array, it's going to take the value of 20 from start. It's going to take the value of 20 from start, and it'll take the value of 15 and move it there, and the end will come one value closer. Does this jog your memory?
Yes, sir.
All right, awesome. So we also have two more functions, and there were two functions that and these two functions are two functions that Jaden spoke about just now. There are two functions that apply both to stacks and queues. So we can use it for both a stack and a queue. And those functions are isFull, right? So we could say int isFull, which will tell us if there is no more space in the structure. Int array, right? We'll check the structure to see if actually no. Let me put the word we'll check this structure to see if it is full and return 0 if it is and 1 if it is not. Okay, so it'll return 0 when it's full and it'll return 1 when it's not full. And we have the same for isEmpty. Int is empty. We could just, because I'm putting a character array into it because I'll just put the word stack or queue, and we will just pass the word stack or queue to see if the stack is full or if the queue is full, right? Because in this program, we only have one stack and one queue. So we don't even have to put an array. We could put S or Q. Okay? So we'll pass isFull S for stack and isFull Q for queue. Okay? So we'll check the structure to see if it is empty and return 0 if it is and 1 if it is not. So we could check to see if our stack is empty, if our queue is empty. We'll see how it goes. Everybody with me up to this point now with the explanation, with a little bit of explanation and the comments on the side. Do we understand what stacks are and what queues are? And where we want to go with it?
Yes,
okay. All right, thank you. All right. So the first thing that we want to do is that we want to pretty much display a menu. So we could use our function for the menu. And we said that our menu options are essentially to add a value, to remove values, to add a value to both structures, to remove a value to both structures, and to display the contents of both structures. Okay? So we can say down here, let me just give a little space. We could say while one, and we call menu. Okay, so our program will always run the menu. So let's create our menu. Void menu. We could create the menu quickly because we know that, the menu is just a bunch of print statements. Printf. What do we want to do? Let's choose some options to our user. The first thing is to add a value to the stack and the queue. All right, we could put a /n to go on the next line. Remove a value from the stack and the queue. /n to go to the next line. Where's the third option? To display. contents of the stack and the queue, right? And the last thing would be to exit the program. Exit the program. Okay. What do we want to do here after? We want to say scanf. Actually, exit the program, \n. Make your selection, :\n, so that it will come out there. Right? We can say have a variable called int opt for our option. Yes? Yeah?
Oh, I was not going to tell you it didn't make the integer for the to take the input as well.
Okay. All right. So at least we watching along. We good? Right? I appreciate that. We have get sharp. So this here, and I'm just trying to keep along with display the menu. And then we have the get the value from the user. And the next thing that we'll do is that we could use a switch case. So we could say switch what? Switch opt case 1 : break. And we can have all 1, 2, 3, 4 and default. You just compile and make sure I have no, right, you have duplicate case values, case 2, case 3, case 4. What do we want to do in the case of 4? We could just simply say printf bye-bye, printf goodbye. Here get char, and then exit 0. Right? So leaves the what? Leaves the program. Okay. Default, we could print a error message in default that says invalid selection made. And invalid selection made, please try again. All right, the get char, and then it should loop back to the menu. Okay, so add a value to the stack of the queue, remove a value, display the contents. Let's enter 7. It said invalid selection made, please try again. And it prints out the oops. Prints out the contents of the menu again. That was my mistake here with that's why it behaved incorrectly. So let's make a selection 4. It says goodbye, it leaves. Okay, well, we halfway there. A little feel so.
So you were sharing like the results page.
Oh, all right, yes, because all right. Well, then I'll go it over. All right. I forgot that I only had it sharing, not my whole screen, but the just one window. And again, why wait until after I'm finished with the whole thing to say that to me? Okay, so we have. Oh, so I was just all right. No problem. If we have option 7, it says invalid selection. If we have option 4, it says goodbye and we leave. Okay. If it is that we have any other option so far, nothing happens because we don't have anything inside of our key statements. Everybody's good with that? Yeah?
Yes, sir.
Right. So the first thing that we want to do is to write the function or the operations that would allow us to add a value to our stack and our queue. Okay? But let's just stop and think about something. In terms of adding a value to a stack or a queue, and maybe we could go back to our whiteboard here. What should happen? Let's say, for instance, my max size is 5. Okay, and I have a stack. So I have 0, 1, 2, 3, 4. And my queue is full. So top is up here. 2, 9, 7, 1, 3. 2, 9, 7, 1, 3. What should happen in this case when I want to say, let's say, for instance, I'm saying push the value of 17 here. I'm trying to put 17 onto my stack, but my stack is at the max value. I need to check to see if the structure is full, not so before I could actually decide to push a value onto it. Agreed?
Yes.
Yeah. So this is where the isFull function comes in. The isFull function will first check to see if there is space to perform this push operation. So our push function could look something like what? If isFull is n = 0, then push the value onto the stack. Not so?
Yes, sir.
Okay. Just making sure, bear with me. Right? So this is what we're going to try to do. And of course, we're doing the same thing for the queue. We have to try and push a value, or sorry, enqueue a value in this for the sake of the queue. If it is that we have the max being 5 and 0, 1, 2, 3, 4, and I'm trying to enqueue a value to here, I should get a message saying I cannot add a value because the queue is full. All right. So let's see if we can write that function that will state what we want. So are we going to another function to do it, or we just to then call the push and the enqueue function, or should we just write the code in the middle here? What do you all want to do? I don't think it's going to be too much code. So we could probably just write the code in the middle there and reference these functions rather than having a function call a function. Okay? Everybody's fine with that?
Yes, sir.
All right. I feel like you're laughing because it's like, so in the grand scheme of things, that doesn't really matter. Right? That's fine. Okay. So what we want to do is that we want to essentially, if we add in a value to the stack and the queue, we want to say, say printf, please enter a value to add to your structures, to your stack and your queue, right? To your stack and your queue. We want to get a value from the user. So we say scanf, what do we call this number here? We can declare it as n. Okay? Scanf %d ampersand n, and we say get char, just to clean up this kind of input, and n is the value. So they say take a value from the user to store in the stack or the queue. And we want to now then say push n and nq nqe n. We're going to put them onto the stack and the queue. Okay? We're going to put them onto the stack and the queue. So now maybe it might be wise to declare these or define these functions now. So we have to write the function void push and void nq. And push should take in a value int num, and q also takes in a value int num. What does push do? Push wants to first check to ensure that this stack has space to put a value. Okay? So push is going to say if what? If they have mounted, right? Is full.
I find it kind of weird in a sense you're writing a function inside of it. It's like you say now going reference call the function, but you're calling is full inside push, and then after you have to go and write is full again.
Yeah, well, that's what we have to do. Because it's full, the code is full, is really going to work for both the stack and the queue. Right? So if it's full for our stack is unequal to 0, what does this mean? It means that we can then add a value to our function. So just stay with me, it'll all come together, right? So what I'm saying here is once there is space in the stack, right, we say top is equal to top plus 1. We say stack at position top is equal to num, right? So move this the top move the top marker to the next free space and store the value in that space. And if it is that is full was not, right, because we say is full returns 0. Oh, right, yes, is full will return 0 if it is full. So we needed to not return 0, right? And then we say else, if there is no space, what do? We want to print a statement. We want to print a statement that says printf, this stack is empty, is full, right? The value cannot be stored. So the stack is full. The value cannot be stored. So this is push in a nutshell. And we could do the same for NQ. NQ is pretty much the same as push, right? NQ is pretty much the same as push. NQ is going to say if what? If is full for Q is equal to 0. What do we want to do? We want to say end is equal to end plus 1, because you move n to the next available position, and you say q at position n is equal to none. So these two are very similar in terms of putting values on. Where we'll see the difference is taking values off, right? And else we could say practically the same thing. We could say the queue is full, the value cannot be stored. Okay? So once there is space in the queue, what do we want to do? We want to move the end marker next free space and store the value in that space. And if there is no space, then we print a message that says the value cannot be stored in the queue. But can we run this as yet? No, we can't. Why not? Because isFull doesn't exist as a function. So isFull is so we want to create the function isFull. And isFull, of course, returns an integer and it takes in a single character, right? Char ADT. So we have to know which ADT we check in to see isFull. The ADT, if the ADT value is S, then it's the stack we check in. So we have to check to see if top is equal to max. Top plus 1 is equal to max. Or if top is equal to max minus 1. Right? We saw that just now. If the max value is 5, then the top value, and the top value is max minus 1, then what does that mean? It means that it's full. Okay? So int is full, we check in that ADT. So we have to check, we say if ADT is equal to S. Okay, if we're checking it for the fact that it's a stack. If we are checking the stack, what do we want to do? We want to compare top against max minus 1. So we say if top is equal to max minus 1, what does it mean? It means that we're full. Right? So I could return the value of 0. Else, I will return the value of 1. And then down here, we could do the same thing for the what you call it, the queue. Right? This will check the queue. It's the same thing. We say if the value in top is equal to max minus 1, what do we want to do? Return 0 because the queue is full. Else, return 1. Look at that. We have the enqueue push and isFull functions operational, right? I mean, I think it will work. Let me see. Why is it telling me expected semicolon? Oh, okay, yes, because I forgot semicolon. All right. Size, not max. Why do I keep using max?
So you forget the semicolon at the end of the return for the
Yes, thank you.
that yes.
Yeah. So far, let's use a smaller maximum value. Let's assume that we could use an array of size 5. After 5 values are entered, if we try to add more values according to what we have here, then we're going to get an error. Okay? We're going to get an error. So we want to add a value to the stack, enter a value to add to your structures. Let's enter 3. Add a value, let's enter 6. Right? So that's the second one we enter. Right? 1, add a value, let's enter 7. 1, add a value, let's enter 8. 1, add a value, let's enter 9. 1, add a value, let's enter 4. It said the stack is full, the value cannot be stored. The queue is full, the value cannot be stored. So according to what we've done here, there is nothing to add. There is nothing that can be added to the stack and to the queue because we filled it up already, right? And again, this is a feature of the abstract data type. It has a specific size. And if it is that all spaces are used inside of this structure, then we will get a message saying that we cannot add any more to it. Okay? Everybody with me so far?
Yes, sir.
Good. So now we want to go on to taking values from the structure. And let's clean this up a little bit now. Let's say every time the menu display I think it's system CLS or CLR. Which one is it? All right, that's system. Never remember how to play the screen.
You think you need the
What is it? CLR or CR?
No, I don't think you need double brackets. I forget what it's called them thing. Yeah.
What is it? What, the quotes? Oh.
Yeah.
All right. No, it's something you had to pass there. All right. Nah, it's looking for it here. I can't remember how to do it. I would like to huh?
Would you like
We will. What's that? Hello?
They're asking if you want me to ask you Google for you.
Yeah, yes. Thanks. I'd appreciate that. All right. I would, but you know what? Okay. So while we're getting that, something, there's a common S. No.
See, it's system CLS. Yeah, that's correct.
Right. It's common S. All right. Okay. So let's just check it out. 1, 2, right. 2, 1, 2, 1, 2, 1, 2. Okay. This stack is full message kind of getting so we can put a get char here to make sure that it pauses on the screen, right? Okay. Yeah. Or I could see if I could just put it. Yeah, I prefer to put it same as true for this. So if let's say we have a stack of size 2, I just want to test and make sure things looking good. All right, we want to add a value to the stack 5. We want to add another value to the stack 8. Right, and that should not come up so quickly. Do I have 2 there? Yeah, so 2, it should have 2 spots. Add a value to the stack 5. on 8. All right, well, I'll look into that in a little bit because it was working when this was greater than 2. So, I know why I stack at position top, Q at position end. Okay, I thought I knew why. This one will check the Q. This is to check the stack, so we had to change end to there. All right. I think that's why I got an error there. Because remember, top is for stack and end is for Q. All right. But we want to move on quickly. You all want to take a 10-minute break and then we move on to the next section? Because I really want to get this whole thing done today. Or you all just want to continue and go through?
So break sounds nice.
The break sounds nice. Okay, well then we're going to take a little break. All right, so 10 minutes, we're coming back at 2:15. Now, if people need a break, they need a break. So at 2:15, we come back and we start promptly then, and then we just run through to the end. I'll stop recording now. All right, so we've started back. What we've done so far was that we've arranged things regarding the enqueuing and pushing onto the structures. Now we want to deal with dequeuing and popping values. So what I would like to do, just because, and again, when it comes to popping and dequeuing, well, popping is easy for a stack because if you have some values onto a stack, 1, 9, 27, 33, right? This is the top. You just take the value of the top of the stack and you carry the top down to the previous one. Okay? It doesn't have to get deleted from the stack per se. It's just remember, once the value at top is now pointing to 27, this value at 33 is inaccessible. So the only way you can get rid of the 33 is to overwrite it with a push, right? But once you use a pop, that value then is taken out of the stack. With the dequeuing, 0, 1, 2, 3, 4, it's a little more involved. Because if I had 15 here and 13 here and 12 here, and this was the end, and of course this is our dedicated start, when I pop this value of dequeue this value of 15 from the structure, what is supposed to happen is that the value of 13 now has to come and so 15 exited, 13 take the space of 15, 12 take the space of 13, and the end marker comes up by 1 to signify where the end is. So we have some iteration to do in terms of putting the values that are next to where the start is, up to the start, up to the end value. Okay, and then we take the end down by 1. So the dequeuing operation involves a little work. We have to write some loops for that. We also have to be mindful of an empty stack or an empty queue, right? If top is here and there's nothing in my stack, or if end is here and there is nothing in my queue, what is there to pull, right? If we do a pop or a dequeue and this is at -1, we have nothing to return. So what do we do in that instance? The way that I implement it, and the implementation will change, of course, whether you're using an array as a structure or if you're using a dynamic structure, is that if there is nothing to return, I actually check for that before I call the function. Okay, I check for that before I call the function. So the first thing that I need to do when I make my command to remove a value from the stack or the queue, is that I am going to check if the queue is empty. So if is empty is unequal to 0, which means if the queue is not empty, right? Well, let me put if the queue is empty. If is empty is equal to 0. If the queue is empty, what do I want to do? Right? And for is empty, of course, I have to put my S here for stack. And if is empty for the queue as well is equal to 0. Okay, so if the stack and the queue is empty, what do I want to do? I want to say printf value cannot be removed from the queue, from the structure. The structures, they are empty. We tell the user there is nothing to return. And we could check that right now, because when we initially create the stack or the queue, ISEMPTY, why is it not giving me? Oh, sorry. Before I run it, I actually have to run the isEmpty or create the isEmpty function as well. So again, int is empty. How do I know whether my stack or my queue is empty? Right? So I take char ADT. And again, I have an if statement. I say if ADT is equal to S. So if the ADT is, if you check in to see if the stack is empty, what do you have to check against? You have to check against top, right? So if to check the stack, right? If top is equal to -1, what do we want to do? If top is equal to -1, you want to return 0. Else, return 1. And the same for the queue. So to check the queue, again, you're checking if end is equal to -1, then you return 0, else return 1. So we know that when we are checking to see if the stack or the queue is empty, right? Turn 0, return. Right. Yeah, once we're checking to see if the stack or the queue is empty, once we get a 0 from is empty, and again, we set that up here, right? If it is empty, it will return 0. If it's 1, it will return, sorry, if it's not, right? If it is, and if it is, yeah, I have some bad grammar here, right? So I say we'll check the structure to see if it's full and return 0. And 1 if it is not. it will return 1 if it is not. And it will return 1 if it is not. So in the case of just having been created, according to what we have, if we select 2 and we're trying to remove a value, right, we first check to see if these structures are empty. If they are empty, then we can't go any further. Otherwise, however, just now we will put an else and say, okay, let's call the DQ function, let's call the pop function, and print out the values from the DQ and pop function. If it is that these values are, if it is that these structures have theta inside of them. Okay? Everybody's with me so far? That's a question.
So you could go back to the is empty function I did, please.
Yeah. So is empty will return an integer, either 1 or 0. If it is that the top is the same as -1, it means that currently there is nothing to return from the structure. If it is that end is -1, it means the same thing. There's nothing to return from the structure. Let's run an example and see. So if we say at this point, this is empty, they're empty because they've never had any value inside of them. We say 2, remove a value from the stack and the queue. Oops, I do not have any get char statement. So my output did not read, all right? So let's run it again and see. Remove a value from the stack and the queue, 2. A value cannot be removed from the structures, they are empty because we don't have anything inside of them. If it is that, of course, I wanted to remove the values, I can't at this point anyway because I don't have the code for it written here. So that's what I want to put inside of here. Else what? Else printf, the value removed from the stack was %d, comma, and we could just pop the value into there, okay? And we could do the same thing, printf, the value removed from the queue was %d, and we have dq. We have dq. Step that in last time, right? So we have the dq value coming out from the value, right? Removed. From the stack was %d, the value removed from the queue was %d. Anybody have any questions up to this point? We are now going to create the pop and the dq functions. Okay? So we want the pop function, int pop, what do we want from pop? Pop simply places the value that is in the current top, places the value in the current top in a temporary place. It decreases top by 1, and then it returns the value that was temporarily placed inside here. So if I say int what? Int temp. And I say temp is equal to stack at position top. Right? Of course, this pop only gets called as long as we establish that the structure is not empty. Okay, then we say temp, not temp, sorry, top is equal to top minus 1. Top is equal to top minus 1. And then we can return temp. This pop function is simple. In order to return a value or to remove a value, we have to check to see if it is empty. If it is not empty, then we just simply take the value that's in top, store it in a temporary variable, carry the value of top down by 1, so that the top now becomes the value that was underneath it, and then we return temp. And I'm just going to, for the purpose of examples, comment out the queue, and let's add 2 values to the stack. Right? So I'm going to say that the size of the stack, I'm carrying the size of the stack back to 5. We say add a value to the stack and the queue, we're adding 15. Right? We want to add another value to the stack and the queue, we have 16. We want to add another value to the stack and the queue, we have 18. What value should we expect to come back out of the stack? Out of the stack? That's a question to you all. What value was the last value I placed into the stack? Jude. Let me call her name. No response from Jude. David.
Hi, sir.
All right. What value should be returned from the stack when I choose option 2? What was the last value put in? Remember, we established that the stack is the last in, first out structure. So I placed 3 values into the stack, and the most recent value was what?
So I'm not really sure. My internet did that thing and then not too long come back.
Okay, no problem. So it should be 18.
Oh.
So the value removed from the stack was 18. And if I call this again, then the value removed from the stack was 16. And then the value removed from the stack was 15. And then, well, value removed from the stack was 0. Okay, so we have some problems because top not supposed to be pulling values that like 0. So we have some issue to work out there, right? Because after 15, top was supposed to go back down to -1. And then it should have told us that the stack was full, right? So top should have been is empty and it should have been returned 0 or something. So we'll troubleshoot that in a little bit. Okay, we'll troubleshoot that in a little bit. We're not ending class before that gets resolved. And the same thing for a queue, right? So I'm putting back DQ. But DQ is different from stack, from pop. Pop takes it from the top, as in the last thing entered is the first thing taken out. A queue should be the first thing entered, should be the first thing taken out. Okay, so the value that is in the oh yes, I know why it didn't work. It is because of my logic here, right? Because I had and here, not I had and here, not or in the case of the queue. So because remember, we should really have the stack and the queue operating at the same time. But in my example just now, I only had the stack operating, right? So I do believe that's something true of my logic for this here. And that is why I was trying to pull from values that did not exist here. So we figured out why our behavior wasn't as desired. But that is because we were working under the assumption that we will always be pulling from the stack and the queue at the same time. Okay? Now, once we write DQ, so we have int DQ, right? And we say for pop, we said that this removes a value from the top of the stack, right? This function DQ removes a value from the start of the queue, from the start of the queue. And that's why I had this value called start all the way up here defined. And start is always at position 0. So at the start of the queue, I want to do the same thing like I did with temp. You have temp. I say temp is equal to queue at position start. Okay, so queue at position 0, I always take the value at the start of the queue. What do I want to do? I want to say from position 0, so going into my notes, remember we spoke about this just now. When we are DQing, what the DQ does is if I had 5 values in my queue, 9, 2, 7, 1, 3, and this is the end here currently, and this is the start, and I just remove the value from the start, every other value should move up by 1 in my queue. So I need to have some sort of for loop that is going to allow me to loop through to the end of my queue and bring that value that is after the start value forward by 1. And then I move every other value forward by 1 until I hit the end value. Okay? So we need to have a counter, I, and we can say for I is equal to 0, which is the value at the start, right? For I is equal to 0, semicolon, I is less than the value or equal to, less than the value in n. All right, so yeah, that's the name of my variable here, right? N. This one here, this is the same n that we're dealing with. So for I is equal to 0, I is less than n, semicolon, I plus plus. What do we want to do? We want to take the value of I plus 1 and make it I. I'm put it inside of I. So we say Q at position I is equal to Q at position I plus 1. So for every value from the start to the end, move the value to the left of the current position into the current position. That's how we do what we just did here. We brought up everything by 1 into this array. Following me? And after we do that, we say end is equal to end minus 1. Just like we did with top, because we took out 1 from the structure. So now the end is 1 previous to where it was. Okay? So let's see if it works. Let's see if it works in terms of adding values. All right, and the thing is, this will now show us that if it is that I added a value, if I added values 9, 3, and 2, for my stack, my output will come like 2, 3, and 9. And for my queue, my output will be 9, 3, and 2. Okay? So for my stack and my queue, they should be reversed, because the stack, as I said before, is last in, first out, and the queue is first in, first out. So let's see if this will work according to what we did. So the first value we enter, 1, is 9. Then we entering 3. Then we entering the value of 2. Now we want to remove values. 2, the value removed from the stack was 2. The value removed from the queue was 1. It's not behaving properly. Let's take a look as to why. All right, so DQ is not behaving as it should. All right, and at this point, what I will do, just for visual reference, is to print for debugging. Print for debugging, and we want to print the stack, and also we want to print the queue for debugging. And for us to print this, we go for, let's give it int I. This I here is for debugging, right? Where's my, right? For I is equal to 0, semicolon, I is less than top, semicolon, I plus plus, printf, stack acquisition. Okay, so we can't panic when things don't go our way. The purpose of what we do is to figure out why it didn't go our way. So stack and queue, right? And let me just make sure that I have temp is equal to queue at position start. All right, I could substitute start here and end here. Q at position I is equal to Q at position I plus 1, and n is equal to n minus 1. So in my mind, it should work, but I might be missing something somewhere. All right, so we'll just print it out before we the values inside of the cube when we're taking them out. All right, right before we take them out. So I'm going to add some values, 5, 6, 7, 8. So if I'm taking out a value 2, right? 5, 6, 7, 5, 6, 7. So we have the values proper. 5, 6, and 7 is the stack. 5, 6, and 7 is the queue, right? The value removed from the stack was 8. The value removed from the queue was 2. We never had a 2 inside of the queue. So where did I get this 2 value from? Int DQ. Tell me what I did wrong. I did something absolutely wrong in this DQ function. I feel like if maybe I see it now and I'm ashamed. Somebody? Nobody? I did it in pop and I did not do it in DQ.
I don't know, sir. You didn't return anything?
I did not return the statement, so I did not return temp.
I was going to I know so, but I don't know.
But what? But it's fine to say it, I have no problem with being corrected or it's either correct or wrong, right? So I didn't return temp, and that's the reason why nothing is being returned here, right? So in terms of this, and I should print out printf a backslash n. Now this should work because heaven knows where the value of dq was pulling data to show here. So let's see if it works now, right? So we want to add a value to the stack. We're adding 8, 19, and 7, right? The value removed from the stack was 7. The value removed from the queue was 8, right? So we have 8, 19, and 7. I needed to put less than or equal to here. So that's why it's not printing out that value. And we can't delete this code because this code actually forms the basis for the next part that we want to do. Okay? So I'm just commenting this code out because we'll be using this in 2 seconds. The last thing, display the contents of the stack and the queue. We want to display the contents of the stack and the queue. And this is actually the code for it right here. So I could copy the code and I've commented out. Right? X. And I could put it right inside of this case tree here. Indent it properly. And let's make it a little prettier. Okay, so we can put in put inside here printf the contents of the stack is, all right, and this will be it up the top. Okay, and we could say printf, and maybe because it's a stack, we could print it stacked up. Yeah, that might be a good idea, right? So the contents of the stack, just put a colon, right? And we want to print out all the contents of the stack, and we can say if I is, right, I want to print top down. So we start at top and let's greater than or equal to 0. So we'll print the contents of the stack from the top down. And we could say if I is equal to top, then print the word top next to it. Right? Printf, I don't need that, it's just one statement. Printf in brackets top. Okay. And print the queue. This one will print the queue, so I could say the contents of the queue. Right? The contents of the QUE. Right? And printf \n, and of course, this one, of course, goes to end. Okay? So this one, of course, goes to end. And we know for a fact that the end of the queue is always on the rightmost side of the queue. So I don't have to do any logic basically to print the end of the queue. I could just print the word end in brackets right at the end of the queue, because the last one to be printed out will always be the end of the queue. Okay, so I hope that makes sense to you, because we're gonna see it now. And we could probably add some logic here that will, if it is that top is equal to 0 or something, you could print there is nothing, the queue is empty. Okay, but we could go without that. So we can semicolon, semicolon. Right, print F. So if it is that we have nothing inside of the contents and we try to print it, nothing prints out. Okay, And of course, I did like everything else, get char to freeze my output. Okay. Right, the content of the stack is nothing. The content of the queue is nothing. Values inside of there. I also want to not just add some values, but right, I have that \n there. So let's add some values to our stack and our queue. So if I put 17, 19, 31, one invalid selection, 33, 27, 27, right? Let's display the contents. And that does not go as planned. Well, it's fun to break stuff, right? And that is because I did not put minus there. For shame, Mr. Valles, for shame. So we have to start over. 1, 33, 2, sign up 2, 1, 27, 1, 19, option 3. So the contents of the stack. Hey, where's my \n to print the stack out like a stack? I wanted my stack like a stack. So I know I need to put a \n here. And also I need to put a \n here. Right? If I is equal to top, print top, then \n. Else just print a normal \n. Okay, because we want the top to be represented by a value that says that this is the top value. Okay? So again, we go 1, 15, 1, 19, 1, 22, 3. So this is the contents of my stack, and this is the contents of the queue. Does this look like a stack? Does this look like a queue to you? Yes?
Yeah, it does.
Right. So if it is now that we go into option 2 and we say remove a value from them, let's see how that works. 2. The value removed from the stack was 22. The value removed from this queue was 15. Okay, good. So if I go back into option 3, I end up with some different values in my stack and my queue. I think that this is a pretty useful program for understanding the way that stacks and queues work. You all don't think so? I mean, we had a couple bugs along the way, but we ended up, we ended up mostly getting something that's pretty useful. Agreed? So we could change this to a large size now so that we could play with it with a lot of values. We could put a \n here so that these things come out on the different lines. And we could probably even print a value that says something that says start of the queue for the queue here, so that we can have a nice looking queue with start and end, there. Right? So let's check it out now. 1, 17, 1, 88, 1, 28, 1, 89, 1, 90, 1, 33, and let's print them out. This is what my stack and my queue looks like. And we know that we always take the value when we're taking off from the top of the stack. And when we're taking off for the queue, we're taking off from the front of the queue. So if we start to remove values in our head, we know that we'll take off 33 from the stack and 17 from the queue. Then we'll take off 90 from the stack and 88 from the queue. So even though we start off with some dissimilar values, let's remove about 3 values from the stack and the queue and then add a couple more values. Okay? So let's remove We take out 33 and 17. Remove 90 and 88. Remove 89 and 28. Let's add back 67. Let's add back 55. And let's add back 20. Now, if we take a look at them, what is it now? These two look like two totally different value sets. Because 17, 88, and 28 were among the first set of values that we ever entered. And then we had 89, 90, and 33. Those would have followed. And then 67, 55, and 20. Okay? The recommended energy drink for this class is Programming Hazard. When you start programming it, it energizes you. Right? So, I mean, you know, at this point though, I think that we've really and truly gone through stacks and queues. This program is a nice concept to be able to understand it. We got to understand pushing, popping, enqueuing, dequeuing, its full function, its empty function, and the nature of how data is added and removed from stacks and queues. Okay? So, any questions? Any questions? You all think it come together nicely? Nobody saying nothing. Oh my God.
So you see how you was like just adding numbers to like the stacks, and it does have a way to like add separate numbers, like different numbers, like add numbers stacks and numbers queues.
Yeah. I just designed this program to add to both at the same time. If you wanted to, you could have written your program in such a way that you could have made the user choose which structure they want to add to and then add it to that structure. Right? But I did that for brevity's sake. All right. Hazard, I'll answer that question when I stop recording. Any other questions related to the topic? All right, so I'm going to stop recording now.
But the output
The output was?
Not the output. Like how looking at stuck. That probably the only good thing is look out. Everything else is just stress.
Well, everything else was stress, but well, that's what it is about. I mean, the thing is a lot of work sometimes it's not that much work. It's only 157 lines, right? It's not that much work. Okay, so it takes less than 2 hours. So we produce more than a line a minute. All right, if you want to think about it like that. And we had some bugs, we addressed the bugs, everything come out looking cool, you know, and it's there. So again, I'm going to stop recording now.